Hello, everyone. And I just audio checked the online as well. It seems to work out fine. So first of all, welcome everyone in the room and also everyone online. It's great to have you here. My name is Henrik Åslund. I have two roles here today. One is as one of the chapter leaders for OWASP, and the other one is to be the host from Akamai as well. So in both roles, great to have you here. All right. So I will do a quick intro of OWASP. Then there will be a very short introduction of Akamai as a sponsor, and then we'll move on to the actual presentations. Okay? So bear with us. So first of all, we have a great lineup tonight. First, we have Handelsbanken with Niklas, Daniela, and Trolle talking about the CI in CI/CD. And then we have Jens and Anders, who's more local and talking about AI and OWASP top 10 for LLMs. So be ready for that. Looks great. This is the chapter leaders for OWASP Stockholm. Me, Davis, and Akka is here today. Akka and Davis, he disappeared. All right, he is here anyway. And we have Shane and Naime joining us remotely. So we are the ones that are spending weekends and evenings trying to arrange good sessions for you all. So I hope you will enjoy it. We certainly do. And it's great to bring the security community together as well. But we also have some help with this. And tonight we have Fatim, who is helping us. And you can also reach out to him to get any guidance if you have any questions whatsoever. All right. So we are always looking for speakers. So I'll leave this here for a few seconds. This leads to a Google form where you can enter some of your details if you're interested of having a speaker opportunity. We're also looking for hosts as well. So if you're representing a company that wants to do something like this, well, feel free to also enter that in there. You can also follow us on LinkedIn. You can join OWASP as a member. And you can also subscribe to the mailing list that we have to find out about the sessions and the meetups before we actually post them on the Meetup space. A short plug for the next event. It's a social event. We arrange those from time to time. This one is at the Old Brewer. It's a pub in, well, I don't know the exact address, but it's in you. You have time to find it. So watch out for that. We are publishing that meetup soon. All right, the agenda. We're well into the intro by now. Then we will have Niklas, Daniel, and Trolle. Short break, and then over to Jens and Anders. And then you're free to stick around for afterwards to catch up with your peers and have another drink. All right. With that, a word from our sponsor.
So since I'm minus 3 minutes.
Du delar din skärm.
Ja. Det är bra. Ska bara hitta. Jag ska klicka.
Där.
So, okay. My name is Alexander. I'm a solutions engineer here. I've been here for almost a decade. But this time last year, I was one of the speakers. I don't know if anyone said them. Yeah, so I'm already a few minutes behind. I'm just going to do some brief overview of Akamai. And our colleagues are going to talk about AI today, right? So you can't really spell Akamai without AI, right? Gonna keep that in mind. But this is also our go away party or our move out, our crash party for this office, because next week we're moving to a new booth location in Epicenter. So next time we're hosting, we're not going to be here. We're going to be at our new office. And but over to so what is Akamai and what's our mission? And in essence, we power and protect people online millions and billion times a day, or we empower our customers to build powerful distributed applications through a simple, scalable platform, right? So Akamai is the world's most distributed cloud platform. Akamai offers full stack cloud computing all the way from the core data centers out to the edge and security along the way, right? We're probably most famous for the edge platform. That's what we've been doing for 26 years. You know, Akamai is the original inventor of the CDN. It's the original inventor of a cloud WAF, right? We've been doing that for almost 20 years too, right? You all guys have probably heard about other companies that may or may burn when they get put through attacks, but the distribution of our platform is the core key. And we built on capabilities on top of that, from security to delivery. And the latest is that we now are doing AI interferencing at the edge all the way through the platform. And of course, we're securing it along the way. So the three pillars, as I said, is edge delivery, cloud computing, and security services, because we all know that tech is cool, but when we don't have the proper knowledge and technology, it's always handy to be able to call a friend. So about half of Akamai is those expert friends of yours that you can call when you really need, or you can simply outsource the whole management of the security setup to Akamai. So just brief, some of the services, I said, you know, we can't really do edge delivery without DNS. Everything starts with DNS. So all the way back in 98, we built the DNS foundation of the services that we still use today. Akamai is the world's largest provider of DNS services. Everyone has heard of Google and 1.1.1 or wherever, but we do over 2 trillion DNS requests on a day on Akamai DNS services and platforms. We have the content delivery network. We had a brief talk about that earlier today. You know, it's in thousands of locations around the globe, and we do somewhere between 250 to 400 terabits per second on a daily basis on that platform. But of course, all that is very cool. But, you know, in the end, we kind of want to build our own things today. You know, this is just a platform. So our customers build applications on this, everything from WASM functions to custom rules in the CDN to create their immersive experience and applications on top of it. It might be streaming, it might be banking, it might be APIs. We do it all. Maybe the lesser known parts of Akamai is, as I said, that we offer full stack cloud computing. We have about 30 core locations around the globe, Stockholm being one of them, where we have a hyper modern data center where we offer everything from classic cloud computer services to GPUs to AI services, Kubernetes, whatever, right? Literally cents per dollar that you spend today with your cloud vendors, because we do this already for us. So we have excess capacity that we sell for the cheap to our customers. So enterprise scale computing for like the average consumer price, right? It's a known fact. and on top of that, you know, we also have the friends and the services that we call about. It might be that we do, as I said, the whole SOC and that part, also the security services, DDoS protection, WAF, API security is one of the big things that's growing rapidly now, where we can, you know, and that's what I talked about last year. And since I was on stage here last year, we've also acquired the leader in that space that was called No Name Security. So they're in our room now. And we're really powering through there and powering that solution with Akamai data, right? Another maybe little less known fact, we talked about it here, and it's, you know, that we also do enterprise security in the data center. So no matter where you host applications, in your own data center, in a cloud vendor, Azure, Google Cloud, AWS, some other third-party cloud, we can create one software-defined logical network on top of that as an abstraction layer, and secure every single application down to the process level, and connect that together with a zero trust network access. So it's quite powerful. And as I said, our customers build applications on our platform. So what would that be without CFCD platform, right? So small segue to you guys. So bring up your phones. I have a last request for you. We know there's a lot of QR codes flying around here tonight, and I cannot promise you that we're not quishing you, but you can at least hope. So take a minute and ask yourself what, and you can see what Akamai thinks OWASP is, right? And see if you agree with us. And then for your way home tonight, I hope you would like to read our latest State of the Internet report regarding the trends and about apps and API security. So with that said, I've now wasted another 7 minutes of your time. So please.
Yes. Welcome.
You go first.
We're going to see if the technology will work for us.
Well. Och som upptäckte så var det lite vanskligt att få. Ska se, jag kan börja
Ja, de borde se ut.
Ja, det ska jag. Det är bra.
Ja, det är fantastiskt. Jag ska bara fixa lite andra saker. Ja, alltså, jag ska jag har inte någon idé idag. Jag är bra till det. Ja. I'm going to try to...
So we are just
doing some stuff in the background. Is it okay if I talk a little bit first?
Yeah, sure.
Great. So we're going to talk about securing the CI in a CI/CD pipeline. We had a sort of name called a pipeline of broken dreams. But the main thing from this came from that we sit together, working really close together, and we had fun thinking about these things and started throwing them around ourselves. That, oh, how should we do it if everything else is sort of done? So that's how we started. So we're gonna walk through everything, but hopefully you will enjoy it. Please ask questions in the end, because we think it's really fun and a really fun subject.
Yeah, and this is what we do all day at Handelsbanken as well. We work with, we are all security architects.
who are we?
Yeah, who are we? Yeah. Who are we? I'm the one in the middle, and my name is Niklas, but we're all security architects and we work with development questions, more or less. More or less all the way from how to protect CI/CD, how to implement DevOps in a large enterprise, all the way to how to build applications and somewhat application security as well.
We're actually called Team Secure Development. So
Yeah.
we develop the security.
Yeah, we develop security in Handelsbanken, I don't know. We're running around. And this is Trolle.
Yeah, sure. Yeah, I can go. My name is Trolle. I started on a whim for Handelsbanken, but I've worked there for 7 years, I think, something like that. Really like American football on my spare time. I like structure, and it's kind of like chess, but you have really moving pieces. So yeah, that's me.
And I'm Daniela. I'm also, I think our official title is IT Security Architects. And I have a background in engineering from KDH and also a background in teaching for upper secondary school in Sweden.
Yeah, and as I said, my name is Niklas Sigurd. I'm also an IT security architect. I started to develop web apps in the 90s, I guess. And then I moved more or less into, when I started work for a larger enterprise like Handelsbanken, the web apps started to be more of like the security part of web apps. And then all of a sudden I just ended up in the security department of Handelsbanken. And I've been there for 6 years now.
Yes, and we're gonna...
Sorry, I just had to interrupt you. Before we go to that slide, we're going to talk about the CI in CI/CD today, right? So we try to focus on the integration part and that part. And I think the things we're going to talk about, I don't think they are new to anybody here. I don't think we're going to say like, oh, I never heard about this before. You probably have control over your CI/CD pipeline as well. We're just trying to puzzle all things together and find what can attacker use here, and how to defend those moving parts.
Yeah. But if you are new to this,
yeah.
I wouldn't start at the thing we're going to demo. Like this slide is meant to stimulate. If you've got 99 problems, if you're just starting, start solving those first. Yeah, solve them first. Next, and what should you focus on? Well, most IT incidents are related to human error. Like, it doesn't matter how messy the world is, how like what's going on. Everybody, as soon as a service goes down, you usually think, "Oh no, they're coming," but more often than not, it's just a mistake. So really, if you're going to start somewhere, focus on automating the processes, make it difficult for your humans to make mistakes, because that's where the big bulk of IT incidents lie. Next. But if it is an IT security related incident, then in most cases, there's a known vulnerability involved, meaning something that we knew that we could have remedied before we were attacked. So, in summary, if you're just starting out with CI/CD security, you should keep calm, get your human ducks in a row, make it easy for your humans to do the right thing, and patch your vulnerabilities. Scan for them and patch them. Yes.
Carry on.
Yeah, and carry on. So, if we got all that sorted, then what? What are we going to do? Take it away, Trolle.
Great. So when starting this, we set out to look for, so what's the goal of an attacker? What do they really want? And from our convoluted minds, we found that, everything leads to that you want to gain access to a production environment, because it's no fun having total domination over a test environment. Hopefully, we have seen some things where you can escalate to production, but hopefully you have those separated. And once they are in the production environment, they either want to do some grab the money and run or something like that, or they want to do some sort of disturbance or outage of our services. So having that in mind during the next thing of our speech, we want to look at, how can this be done? How can we gain access to production from this CI pipeline, or the CI part of a CI/CD workflow? And we have found that you can do it in multiple ways. You can have a vulnerability, or you can grab credentials or other types of authentication methods to be able to gain access to the production environment. And this is some sort of defender's dilemma, that we have a lot of places where we want to protect. It's hard to protect every instance and everything that is involved in the thing. So let's move to next.
Yeah, and here we have all these complex moving parts. And this is sort of how we think CI and CD are separated and what they involve. So we're sort of building the code, doing a lot of static testing here, unit testing, and quite confusingly, I mean, CI stands for continuous integration, but we actually believe integration testing should be done here. We should get our code securely to our build server, test it, build it, sign it, and then publish it to an artifact repository. Then we have our CD pipeline who takes the artifact, does integration testing, and promotes it throughout the test environments, and finally to production. And for the rest of the speech,
Sorry, I was too quick.
For the rest of the speech, we're going to assume that you have this is under control. We're just going to look at this part for the rest of the speech. And we're also going to divide the CI part in two different separate parts. We have the sort of developer environment here, where the developer works, builds their code, and then commits it to the version system. And then we want to get it as securely as possible, because this environment is usually seen as more dirty than the build server. So we get it securely into the build server, and then we build it, we test it, assign it, and in each of these steps, we want to make sure the previous step was conducted successfully and nothing was tampered with in between.
No.
Maybe.
Yeah, there we go.
Great. So let's divide this into the attacker's mindset again and look where we can potentially gain access or gain something from this chain. And bear with us, you're going to have a lot of text there. Don't worry about the text, okay? Just don't worry about it. So we have one potential weakness. It's the developer's computer. So here we can also see that developers usually have a lot of high credentials or other stuff. They have access to maybe so-called production systems in case of mail or Teams and chats and stuff like that. We can see that often the goal here is to gain information or gain tokens or credentials. Move to the next. We have the version handling system. And mainly what we want to do as an attacker in a version handling system is both impersonate other people. So I don't want to tell them that it's Trolle doing something wrong. I want to tell them that it's Niklas or Daniela that does something. Or I want to modify or change the history of what has happened. Then we have third-party dependencies. As you've heard, we have vulnerabilities and other things. We can always gain a way into the organization. After that, we have the build server. And the build server is really, really interesting because a build server is the thing that compiles our code for production. So if we can somehow gain a grip of this build server or inject something here, we know that, somehow further later down the road, it's going to be run in a production environment. After that, we have a test server. As we said, hopefully we have separated test and production, but otherwise we can have a potential way if we have some sort of cross connection between them. And after a while, we come to the storage integrity, where we store the binary that has been built or compiled. And here we can see that, if we can change an artifact here, or if we can introduce some sort of malicious code as dependency, it's a really great way of gaining access to production. So for this talk, as you have understood, it was a lot of text, it was a lot of things. We realized that we only have like 30 to 35 minutes and then questions. So let's focus on two of them. So for this, we've chose to focus on the developer computer and the build server and look into, okay, how can we gain information tokens or somehow escalate ourselves to production from these two points?
Yeah, and we're going to try to make a live demonstration for you guys here. We have some slides, but we're going to try to make a live demonstration here. And we were thinking like, how should we do this demonstration? And we thought like, we think like an ordinary attacker. We try to use the attacker mindset here. And it's like, so we're going to create a malicious NPM package. We didn't publish it to NPM yet, so we have it.
Don't worry, you can't.
Yeah. Yeah, we have it on file on my computer, nowhere else. Oh, we have it on actually in the version system. And then we're going to use the feature pre-install script. I don't know how many know about NPM lifecycle when you install something. Yeah, perfect. And the lifecycle for NPM is like you have a pre-install and then you install it and then you have a post-install. And when in the pre-install phase, you can actually run anything. It's arbitrary code execution on the developer's machine if you like to. And I think most of JavaScript developers know that. And the NPM people definitely know that, and they think that's a great feature. Because when you want to install a kind of complex JavaScript library, maybe you need to create catalogs or folders or what you want to do. But as an attacker, that's perfect. So that's what we're trying to do. And as I said, we didn't publish the code on some repository, but to do that, I don't know how many have read the Backstabber's handbook. No, okay. No, one. Great. So in that paper, there is a supply chain attack tree. So if you say this is a perfect guide for you to attack some open source community. So just to implant your malicious npm package in somewhere, you just follow these steps, and then you have it. So just pretend we follow some of those steps, and now we have an npm package live. And we're gonna, as Charlie said, we're gonna focus on the developer computer and on the build server. So we're not gonna go into the Git and try and impersonate people on the Git and stuff like that, because that's another angle, right? We have the pre-install phase here to work with. So we have the script that we want to run somewhere. So and we're going to run it on the developer when the developer develops, and then the developer pushes code, and it ends up on the build server. And there's a hook that automatically compiles it and tries to shift it on. And as I said before, so what are we going to focus on when we land in the developer computer? So okay, the developer probably has tokens, right? So there's probably access tokens and different tokens that we want to grab and run, and then use those tokens to later on access production, hopefully. So okay, I'm going to try to do live demo here. So I need to expand it, right? So now I'm probably.
Can you enlarge it?
No, I think. Is it okay? Yeah. Great. So now I'm pretending I'm a developer. So I'm going to develop a JavaScript application of some kind, and this is my. And my project is called Malicious Code. I mean, probably if I was a developer, the project wouldn't be called Malicious Code. It would be called something else. Like so, this is my playground. And this is Sean, the test branch here. So you're the one who made the code. But you have to imagine that you are a developer and developing JavaScript application. And here you can see like I have I do like this. Instead, like I have a test application. That's my application. So I'm going to try to move to my test application. Here I have the ordinary application. I have index.js, that's where I put my logic and stuff like that. And then I have some package JSON. I do like that, and I see like okay, here I have a dependency, and I have a dependency to a JavaScript library called my Trojan friend. So again, you have to pretend that this library is some kind of this library is color or something like that that puts nice colors on my console logs. So when I do this, I just do npm install. My glasses because you can see it like that. And this is what the developer sees, right? Slowly, something happens. If I was a developer, I would be going crazy. But okay, so this is what happens. I just install this my Trojan friend, and it says npm install. What are the 3 packages in 7 seconds? I found 0 vulnerabilities. Hunky-dory. Everything's fine. Me as a developer, I was like, great, I push this to production anytime. That's perfect. So let's dig into the code. I have code somewhere. Yeah, I have code. I will do like that for presentation purposes, right? So this is the library that I had a dependency to. This is called my. You can't see anything. Kan jag göra så här? Jag bara förstår jag. Please. Oh, thanks. You need hacker skills to do that. So this is actually you see the npm package my Trojan friend here. It's like and my Trojan friend. This is the. I will show you the package JSON first. So here you see that this is the package JSON for my Trojan friend. The malicious package that I published on npm.js previously before the naive developer just made the npm install. So you can see here, it's a pre-installed script, and the pre-installed phase is just runs a shell script, right? You can run any code you want to have there. So you can run anything. You can pick up a shell there. And here you feel like I just run my PowerShell script that steals my tokens. I'm not going to go into the token part here, but and it's This demo is kind of not so great, but it's at least a demo. Can you show the tokens file?
Yeah, sure.
I should show you before that I didn't have a token file. Now I have a token file. Yeah, so here, all of a sudden here, you see I have a token file. And the malicious code script stole all my access tokens, put them in a file, and put them on my desktop. And of course, if I was an attacker, I wouldn't put them on my desktop. I would like curl them to my command and control server or whatnot. I would send them somewhere else. So these are actually obfuscated tokens that I had on my computer. Have on my computer right now. So it's as you see, the point here is that it's really hard as a developer to see what's going on when you write npm install. And if you have malicious code and npm.js, you can actually run arbitrary code on the developer computer and steal tokens. And now the attacker can just use those tokens to log into production system if they are valid.
And it's a great way to gain a foothold because we're running something as a user. Here we just show you that you can access the tokens. But since we're running as you on your machine, I don't see how a security team will find out that you're using your tokens to access the services that you have access to. So the network traffic doesn't seem that weird right now because it's generating from your user doing stuff that you should be able to do.
Oh, 10 minutes. So maybe I just show the log from the build server. So now that you have to imagine that då måste jag på rätt steg också. So now you can imagine, like, me as a developer, I was like, I made npm install, I wrote my logic, and my tokens got stolen, but I'm still happy because I have no clue. So I said, okay, this is great. I'm going to push to production. So I just pushed the thing, and all of a sudden the build server, they have a CVS hook, and it's like, oh, I have new code to compile here. So the job starts on the build server. So here's the example for the. We made two stages here, right? So like the ordinary npm install where you don't see anything. So even the Azure DevOps logs will say like, okay, I just made npm install here. So the build server will say the same thing. So if you, as a security-minded developer, looks really close on the logs, it won't say anything. It just ran a pre-install script in the background anyway on the build server. So this is actually the same output as on the developer machine. Can you click on the? So here we just send a foreground script enabled parameter. But then I went to Trufflehog. Oh, just that. We should have Trufflehog here. Sorry. And as you can see here, I have the different script running on the build server than I had on the developer machine. Because on the developer machine, I wanted to steal those access tokens. And probably on a build server, you maybe don't have the access tokens as an individual. You probably have maybe one or two access tokens to some test server or something like that you want to send something, but you don't have those juicy access tokens to production probably. So what can you steal on the build server? And what we did here was like we installed Trufflehog.
What is Trufflehog?
Yeah, what is Trufflehog? How many knows what Trufflehog is?
Great.
Yeah, most of the people. So it's I don't know actually what is I don't know the definition of Trufflehog. It's a truffle hog that finds secrets.
It's some kind of scanning tool to find secrets and the stuff to exploit on the machine it's running.
Exactly. So we downloaded actually the npm pre-install script, downloaded Trufflehog to the build server, and ran Trufflehog on the code that the developer has developed and tried to find secrets in the code. And of course, you shouldn't have secrets in code, but everybody knows that there will be secrets in the code somewhere. So here you can see this. We have the simple if statement. If you are on the build server, then you download the Docker image from Trufflehog and you run it, and then you scan the code. Can you show the result? I'm going to go. Yeah, thanks. So you can see further down here. You have to scroll down right. Yeah, this developer Niklas Sigurd, he was really allows it. It puts, oh, you have to make it a little bit bigger. You can't see the thanks. So you can see here, here's a raw result. It's a MongoDB server. It's a connection string to the database. And that's jackpot. So I say like, okay, great. I have, and then I mean, as if I'm an attacker writing this malicious package, I wouldn't just log it out. I would curl it to my command and control server. So now I have the credentials to the database server, and then I can log into the database production environment, and I grab the money and run, of course. So that's basically what we did here. And that's just two simple examples of grabbing stuff from the developer computer, and the developer doesn't know anything, and grab stuff from the built environment. Can you switch to the script? On the time, 5 minutes. Code, please. Yeah. And as you can see here, what we did before, let's go a little to vänster. So on the developer computer, we use PowerShell, but on the built environment, we use Docker, right? So we downloaded the Docker image from Travelog, and we did. And what I think is kind of fun here is like you have kind of if you think about living on the land, it's like when you run on a build server, I can download Docker. I mean, the build server we used here today was like Ubuntu latest from Microsoft hosted build servers, and that has millions of of different languages, programs, stuff on it, and it's free access to internet. So it's whatever tool you want to use, it's available by the build server.
And living on the land is using existing tools to do your attack. One, for convenience, you don't have to get malware onto the build server, but also to avoid detection, because Docker is probably allowed by the enterprise, so it won't be noticed by surveillance.
And also, I have internet access, so I can download whatever I wanted to download. I can download from my own Docker repository where I have malicious code as well. That's basically the demonstration.
We have some conclusions, don't we?
Yeah, okay, we have more. But yeah, for the demo. That's basically the demo. Yeah, so we didn't decide who's going to talk about this.
For it.
Okay, I'll go for it. Countermeasures. So now we demonstrated that it's really easy to, if you get a foothold in some open source project, it's really easy to plant a malicious code on that run as the developer and run as the build server in the environment. So if you're able to plant malicious code, you're basically home free. You say like, ka-ching, I got the money. So what do you do about it? So some kind of countermeasures. For the development environment, endpoint protection. You have to treat your computers, developer computers, with care. You have to have endpoint protection. You have to have the defender for endpoints or whatever you have, stuff like that on a computer. You have to monitor. You have to maybe whitelist internet. Do I have that here?
Yeah.
Internet access. Yeah. Internet
not
access.
just have free access to the entire internet, only what they need.
You preferably have the least privilege for the accounts. I mean, like you have, as Charles said before, like you probably have a production environment access to Teams and to Microsoft Outlook and SharePoint and whatnot. Maybe you should have different accounts for development and communication with your friends or colleagues. At least the developer accounts should have least privilege. Beep. Finish on.
Well, for the build server then, what should you do there? Well, we recommend short-lived servers. We don't want persistent servers that if they get corrupted, we just want them to die after the run. We don't want to have them. Although we have a thought here. It's not just, if you have short-lived, it's not just green grass.
Yeah,
the attacker will have a different approach.
Yeah, for the short-lived services, definitely. And for the long-lived, I just want to add, we wrote earlier in the presentation, we didn't focus on it then, but you can gain a foothold. So if you gain a foothold, you can maybe I don't know, you install some kind of command and control server on the build server. Then you, as an attacker, have a foothold into the organization at the build server, and then you can.
You can contaminate other.
The project.
If you share a build server between projects, you can contaminate other projects as well.
Yeah. If you have short-lived build servers, you probably have different problems because maybe your organization doesn't want to have the infrastructure by itself. Like our demo here was using Azure DevOps, and we built it with the latest Ubuntu Microsoft hosted build server, and they have everything. Like so, it's pretty cheap. So it's cheap and easy, and you have to run it. If you want to have short-lived build servers inside your organization, it's probably going to take. You have to muster up some energy to do that. So you have to manage your images. You have to run them somewhere and stuff like that. You have to have some kind of management software to manage all those spinning up and down images, right? And you should control internet access before. Living on the land, talk about living on land, preferably your own image with the exact tools that you need to make a build. You slim down if you have a Java project, why should you have NPM installed on it? Why should you have Docker if you have an ordinary Java project and stuff like that? So just keep it as slim as possible. And you have to monitor activities on the build server as if it was the production server. So when you see those, you can't, as an organization, you can't treat the build server as the developer crash and bang box. You have to treat it as a production environment. And more countermeasures. Choose your battlefields. Overall here, when you see like all the different parts here, like you should try to tighten your security as much as possible so you know where you have your problems. So you automate stuff, streamline stuff, try to make the organization move in the scene. Everybody moves. You get your ducks in a row. Yeah. so everybody and does the same thing.
Like choose where the attacker will arrive, and monitor that. So choose where you want to meet your attacker. Yeah. Is it on the build server? Probably not. Maybe in the WAF where you can filter them out.
Yeah, exactly. Yeah. And view the pipelines as initial access. If you follow the meter attack enterprise matrix, like supply chain attacks, and those are all initial access. And the CI pipeline, you should view it also as initial access. So you see, like this is where the attacker gets a foothold. It's like the initial access and try to get foothold and move sideways to the production environment. And that's what you try to stop. Boom. We actually exactly in time.
Well, I think it froze.
Okay. I was so happy. Okay. Almost. Yeah.
Comment. I read a report from Sonatype to create Nexus. They did a scan of 5 million dependencies, 700,000 malicious ones.
Yeah.
So about 15% of the ones are malicious. Question. You guys work with security for DevOps and architecture and products. Success story, like, do you yourselves work with the pipelines? Do you coach other teams? How do you work and ensure that they do the best thing? Don't download the artifacts in the build agents. Do that beforehand. Put them somewhere. Like, how do you get that into the organization? Because it's a bit bigger than you think, right?
Yeah, fear.
Thankfully.
Fear. Do we have any good?
We can't, of course, disclose exactly how we do it, but we have a lot of different approaches. We have a coaching role where we try, if we can avoid it, we don't want to like smack people on the head. But we also know that like people just want to do their job. So if something is possible, they will do it. So we try to have as many like technical controls as possible. It should, because if it's possible to download a vulnerable library, they will do it. So we try to put in as much technical controls as we can. It's not always possible, so we also try to encourage our colleagues to adapt this skeptical mindset that should I just grab a dependency willy-nilly? Now maybe okay, it's perhaps in the short term cheaper than developing it myself, but then I have to maintain it and have those discussions, plant those ideas. So multi ways of dealing with it. You want to add something, Charlotte?
Yeah, we also have kind of a COP for the whole organization, and we have then repos and stuff like that with templates and stuff where you don't have to build it yourself. So we have maintainers and we have community-driven maintaining of stuff that we do all the time, so you don't have to maybe know how to do signing of a Java file or a C# project or something like that. It's already built. We already have it. It's someone that's going to supply code for it, and you just reference it in your pipeline.
And same with static code analysis and stuff like that. So we have templates. Please use templates. And yeah.
Yes.
I think you.
Yeah. So semi question, maybe pushing you a bit. So early on, you said that you were focusing on production environments because the holy grail of an attacker is production. And I would actually disagree with that, because when we do micro-segmentation projects, or most common thing that we detect in all type of organizations, you are representing a very well-funded and resource-strong organization. So you're probably very lucky, and you said you have people doing stuff for you. Good for you guys. But not only in small organizations, but even in research organizations, because they are the ones pioneering micro-segmentation too, right? The most common thing we find when we map out the complete network is cross-links and unknown relationships between development and production environments. So please focus on that too.
Yeah, and we understand that, and I think that's a basic hygiene. Like if you have those
It's
types
one
of
of the 99
connections,
problems.
if you have those, please fix them beforehand.
Absolutely.
Like,
I would say that 99% of the organization doesn't know about them because they are some forgotten clone or fork of some.
Human error. You can't keep track of it manually, and you need to get it under control.
So basically, it's a supply chain attack. If I'm not wrong, is the dependency confusion is the root cause of this incident?
Yeah.
They should have.
Yeah, dependency could be a root cause, of course. But if you look at the if you look at the attack tree, there are several different ways. But
Speak.
But as a developer, because you can have a typo squatting or whatnot. Like the famous is like color, right? So color is spelled differently in American English and English. And one of them was malicious, and the other one was the perfectly legit coloring JavaScript library. And which one should you choose? Yeah, it's totally impossible to do that. If you knew one was malicious, but you don't know which one is malicious. So, but also if you say like dependency confusion is like you create a new package that's are very similar to some old packages, but you can infect in existing packages. And I think the most popular way of doing that right now is taking over a dead open source community and just say like, oh, I can maintain this. Sure, I do this on my spare time, no problems, and then you're in.
The thing here is that we chose to do this via dependency, but that just also because we wanted to attack both the developer's computer and in the pipeline. So if we had just chosen to gain access to access tokens or to a primary refresh token or something like that in a Windows computer, then we could have chosen a multitude of different ways to gain that access, so to say.
Yeah, I'm just going to let in a couple of questions I got from the chat. So I'm just going to read them up. And so regarding the build server, why not have it air-gapped, or at least possible to be air-gapped? You're sure you have your SBOMs under control.
And that sounds
it's a really good idea.
But you're going to have some sort of reflector to artifactor or something like that, since most of the things we want to build, if it's Java or if it's JavaScript or C# or something like that, it has some sort of third-party dependency. But we agree with this, and we think that you should take care of your dependencies in an environment that isn't going directly to npm or NuGet or something like that. You should handle them.
Download and scan them first.
Yeah.
Okay, and the second one is, why do you need an internet access to your build server? It can use an internal Artifactory. Further build servers should have segregation and should not have secrets.
Agreed.
Totally agree.
I have a question regarding, is there anything being done on the other side regarding like these packages as a developer? It's the npm install, that's like very easy for a developer.
Yeah.
Install in React a lot of packages. Those packages are uploaded somewhere. And as you said, color and color, one is malicious, one is not. On that side, is it work being done to find who's trying to upload a malicious packet somewhere? Like these kind of work.
The different technologies, different methods, right? Like Maven, you don't have a central repository in Maven. You have Maven Central, it's called, right? I haven't developed Java for ages, but I think it's Maven Central. But then it's distributed, so you can upload your package to one of those hosts, what are they called? npm is actually centralized, so there is only one database. But and they are working hard on this. I mean, it's really difficult as a developer or IT security architect to have because the developers need the third-party dependencies, and I think you need instead like trust them that they are working on it, but trust by verify. So you have to have some kind of process, and at least you need to think about how you download dependencies. So are you going to do full cowboy and say like you can download anything you want to do, or do you have some kind of repository in between that you download them to first, and then you scan them there before they end up in a developer machine, or is it just bouncing through the Artifactory and ending up in a developer machine and you scan them and you read the reports later? You need to have this process worked out in your company. And
also to have fearless developers or developers that doesn't feel like holy shit what I'm doing, because for example these types of tokens, they're accessible for the users. So as long as we can run it in user space, we get your tokens. So we might want to secure the machine and secure what the machine has access to and what the account that runs on that machine, the developer's account, what it can have access to. So the developer doesn't have to fear every time he wants to try something new. So we put that in a sort of a standard environment.
Yeah.
And just another comment, like the npm part, like that whole area, like installing, for example, React with something gives you like 500 packages. It's like insane the way that works. So
you can have the process like saying like, okay, we have a security. We say like we have a security department who's going to read every line of code from the third-party dependency. It's impossible, right? So you need to have some static code analysis and stuff like that in place, because you can't read millions of lines of code.
Yeah, and also like buy-in and understanding from management. Like a few years ago, when I did a master thesis, I interviewed a couple of managers, and one of them said, "Well, they can. I don't want my teams to like. They can take some decisions. My department, they can take some decisions on their own, like taking an open source library for free that doesn't have any consequences." And I was like, "Oh shit." He doesn't know. Like, of course, it doesn't have financial consequences unless he's unlucky and they took a bad license. But also, like the maintenance cost of having all of these dependencies, making sure they're not malicious, scanning them, keeping them up to date to the latest version. That's a lot of cost in maintenance. And perhaps a lot of managers think, well, open source is free, and like building it yourself is just stupid. Well, no alternative is perfect, but both have consequences. And previously in the industry, I think a lot of managers thought open source was free, but it certainly isn't free. And they may need your support in understanding that.
But to follow up on that also, like I think like at least like in terms of like day to day, you sometimes get the situation where it's like, yeah, if you build it yourself, that's 2 weeks. But if you install this package, it's it's done in a day.
And it certainly has its use cases. Like it's not, but it's not consequence free. Like it has the costs that you have to keep track of, and be able to replace it if it dies. And so, but certainly, like if we were to build everything on our own, it would take a really long time. So it's all your marry and you'll be unhappy. Don't marry and you'll also be unhappy. Like it's,
there's no way around it.
Interesting. Yeah. And this world moves so quick as well. I was reviewing an open source library for a couple of years ago, and I was writing a report, and then I found a vulnerability in the library. So I fixed the vulnerability and I made a pull request to that community. And one of my findings was that this community is thriving. It's good. They have support. They have developers and stuff like that. And then I made this pull request, and nothing happened. It was dead, and nobody approved my pull request. And then I see like there's no more commits to this, and everybody using this or maintaining this moved on to another project. So during that week, I wrote the report. The movie was meant like Ghost Town. So it was like, okay, it's so quick. So I mean, even if this library is fully maintained and everybody likes the library today, it doesn't have to be that way tomorrow. So even if you trust it, you built a very important piece here in my tech stack is open source. Yeah, it's good, but maybe tomorrow it's abandoned. You're not sure.
But if you have the processes to always look into what libraries you have, how they're maintained, like then maybe you can catch these things before it gets too long.
Yeah.
Yeah.
Maybe those kind of processes also.
But it's difficult and hard.
It's
hard problem.
Yeah.
Oh yeah, we have to stop.
Yeah, thanks.
Thank you. Thank you very much. So we, not despite this beautiful guy, we were running a little bit late. It was all my
It's a little bit on us though.
in the beginning, but we have a short break. So we'll start the next session at in 15 minutes, 7:15. Take some more drinks, eat some more wraps, and chat with each other. And for you guys and girls online, we'll be back 7:15. So go grab a coffee.